Okay, guys, let's look at a few concepts today pertaining to remainders, but in the context of factorials. So uh, let's start small with a small example. So we know that we know that n factorial is defined as the product of first n natural numbers, one from starting obviously from 1 to 2, 5. We take the product, so on and so forth till n. This is the value of n factorial. So for example, 3 factorial is nothing but 1 multiplied by 2 multiplied by 3, right? That is 3 factorial for us, which turns out to be 6. Similarly, 4 factorial is 1 into 2 into 3 to 4 is 24. Okay, okay, this is one. Now, let's explore. If I need to see the remainder when when 2 factorial is divided by 3, how much do we get? So 2 factorial is 2. So 2 when divided by 3 obviously gives me a remainder of 2. Very, very, very clear, right? Okay. Now we are taking an example where the number that we divide by is always going to be prime. So let's take that situation where the number that we divide by is always going to be prime. So in this case, for example, it is 3. 3 is a prime number. Okay. Similarly, remainder when, so next prime number is 5. So let's say we take 5 and we take 1 less than 5, which is 4. So 4 factorial. So how much is 4 factorial? 4 factorial is 24. 24 when divided by 5 gives us a remainder of 4, isn't it? Okay, let's look at the next prime number. Remainder when, so the next prime number is 7. So let's say 6 factorial divided by 7. How much do we get? 6 factorial is nothing but 720 divided by 7, which gives us a remainder of 714 is a multiple of 7. So 6 is the remainder that we get, right? Now, do you notice one thing common across all these remainders and the quotients and the divisors that we saw? If this prime number that we are taking is denoted by P here, let's say 3 and 5 and 7s are all can be called P as a generalization. All these numbers that we have taken in factorial are P minus 1 factorial. Okay. So basically, when we divide P minus 1 factorial by P, the remainder that we are getting is always P minus 1. So here we got 2 when 2 factorial was divided by 3. Here we got 4 when 4 factorial was divided by 5. Here we got 6 when 6 factorial was divided by 7. So if I extrapolate this, I can say that if we divide P minus 1 factorial by P, where P is a prime number, the remainder that we will get is P minus 1. So if someone asks you, now all these examples that we took are very much, countable and are smaller in scale. But what if you get a very large number? Suddenly, the entire situation escalates, right? So, for example, if you get something like, let's take a bigger prime number. Let's say we say 97. So if 97 is a prime number, so if, and the question is if 96 factorial is divided by 97, what is the remainder? Now, applying the same extrapolation logic and this uh, rule that we saw above, we can say that the remainder will be 96, isn't it? So we can keep on increasing the divisor's value to any prime number, 3 digit, 4 digit, 5 digit, 6 digit, it doesn't matter. The rule will still apply. All right. So that's what I wanted to discuss. There are various applications of this. So, for example, um, one next level of this is that you'll see if I take this example, if instead of 2 factorial, if I had taken 1 factorial divided by 3, if I had taken 1 factorial divided by 3, the remainder would have been 1. If I had taken, instead of this 4 factorial, if I had reduced that by 1 and taken 3 factorial by 5, 3 factorial is nothing but 6. So 6 by 5, remainder would still be 1. If I had taken, instead of 6 factorial, 5 factorial divided by 7, now 5 factorial is 120. And yeah, and 119 is divisible by 7, so remainder will again be 1. So now we are getting an interesting pattern. So see the difference between the quotient here and this divisor here. So basically, if we are dividing by p, and this is p minus 2 factorial, then the remainder is always 1 in every case. So here also, if this is p, this is p minus 2, this is also p minus 2. So from here, I can generalize the expression as if p minus 2 factorial is divided by p, the remainder will always be 1. Okay, this is a generic rule. So if I extrapolate it and now say that if I have 95 factorial and if I divide it by 97, what is the remainder? The answer is 1. That's it. All right. And remember that this number that we are dividing by, the divisor, uh, this rule is applicable only if these divisors are prime numbers. Okay. And then Uh, there are further use cases here, but I will not go into those because they are not in the context of the GMAT. They go beyond the scope of the GMAT. So knowing this far is good enough. So if you can practice a few questions on this, you should be good to go. Thank you.